This conference is brought to you by CallStack, your React and React Native development experts.
My phone has 6 CPU cores, and I think it would be really great if React Native could make a good use of them with worklets everywhere. Hi, I'm Tomasz Żelawski. I'm a software engineer at Software Mention, working in the React Native open source team. And I'm also a maintainer of the library react-native-worklets, which was extracted from Reanimated. And today, I want to tell you what is the future of worklets and multithreading in React Native. But to begin with, we need a little reminder of what exactly a React Native app is. And a React Native app is just a simple native app, which means that it has the main thread, the UI thread, but what makes it unique is that it has the JS thread. And the JS thread executes some of the JavaScript code. And what it does next, it translates this code, the React tree it produces, to the UI thread, which makes a native hierarchy of views from this tree, renders it on the screen, and voila. This is how React Native works in principle. And this generally takes 2 of our cores. So what about the remaining cores that we have? Well, turns out that the JS thread actually does a lot, because this is React Native. Our whole app is in JavaScript. So everything is happening more or less there. And we could single out some of the tasks that the JS thread does in the context of multithreading and divide them into numerous categories. So to get a few examples of that, what the tasks are, first and foremost, we have the React tree, so handling your JSX, handling your hooks. Then we have animations, probably with React Native Reanimated. We also have gestures with React Native Gesture Handler. Going to more general things, we have things like data fetching and processing, HTTP requests, general API calls. Sometimes we might have some heavier operations, cryptography, end-to-end encryption in chat apps. If we use a camera, we are probably using React Native Video Camera for camera frame processing. And finally, we can also directly access the GPU with libraries like React Native Web GPU. And all of this is happening on the single thread. And the other cores are just sleeping. So I think it's time to wake them up. And to wake them up, we need to talk about the execution pipeline of JavaScript in React Native. Guys from Links already made a great introduction to this, and also I think most of the talks touched some bits of it already, so you're already familiar with it. And we have our JS thread that has all these tasks, and all these tasks are in JavaScript. But the JS thread doesn't run the JavaScript on its own. It needs a tool that actually understands JavaScript. And this tool is an instance of JavaScript virtual machine, which in case of React Native is the Hermes virtual machine, which we refer for short as Hermes runtime. And this runtime in particular, I like to call the React Native runtime, because this is the runtime where React lives, and this is the runtime created by React Native itself. But going back to our course, the ideal situation would be to get these JS tasks, distribute them among the cores, and get them running on the React Native runtime. It sounds great, but it's impossible because by design, the JavaScript runtimes are single-threaded. And this is good because due to this design, the JavaScript code can actually be interpreted quite fast. So what do we do in this situation? Well, I say it's time to get creative. And let's start small. Let's not do all of the tasks at once. Let's start with priority tasks. And what are the priority tasks in your app if you think of multithreading? Well, these are the tasks that have direct interaction with the user interface. So animations and gestures, and obviously the React tree, but the React tree has to stay on the JS thread. If we were to move the React tree to another thread, then basically we are making links v2, I guess. And so to do this properly, to offload the animations and gestures, we have to offload them to the UI thread, because this is the thread that does the rendering and the thread that has a direct access to events. So we don't want any delays. Thanks to that, we have smooth animations and responsive interactions, which are crucial for every React Native app. But still, we have now 2 threads and 1 runtime. We have the same problem as before. So what do we do? Well, it's simple. Let's just create, oh, I went too far. Let's just create another runtime, which we're gonna call the UI runtime, because it's gonna be running on the UI thread. And this looks great in theory, like we solved all our problems, except for the fact that we didn't mention that this guy, the JavaScript bundle, exists only on the React Native runtime. Because when React Native loads, it loads all of the JavaScript code, the bundle, to its own runtime. And unfortunately, we cannot move this bundle to the other runtime. It's the design of JavaScript. What's even worse, it's that we can't move even a single function from the React Native runtime to the UI runtime. It's just not possible. I think we could compare this problem to a problem of moving a file between 2 PCs like this, which I think we would all want that it worked, but it just doesn't. So we are stuck at this point. And this is exactly why in 2020, worklets were invented. So what is a worklet? And the ever enigmatic worklet directive that you have to write in numerous places. Well, if we go to the documentation of React Native worklets, we can find the following definition. A worklet is a short-running JavaScript function that can be moved and executed across different runtimes. But we just said that the JavaScript function cannot be moved between runtimes by design. So how does it work? It starts with a simple bubble plugin, which used to be called the reanimated bubble plugin, but since the library is out as a standalone, it's now called the worklets bubble plugin. But I don't think I need to introduce it, because if you're a React Native developer, you've seen this error definitely more than once. Failed to create a worklet. This happens when you forget to add the bubble plugin to your bubble config.js file. And what does this plugin actually do? It does some transformation to your code while it's bundled into your app. So we have this simple example of a function that uses user-animated style from reanimated and has a worklet inside. Well, the worklets bubble plugin is going to take this function, this worklet, and change it to something like this. So it took the function out, and then it appended a code property to it with the whole code of the function. So we have a function that has a code property now with its code. Sounds a bit silly, but this is the only way to get the code of the function in runtime like this. And the actual transformation is actually a bit more complicated. So you see, this is a very, very simple, very short function, and we get such a long thing. But the key thing is still this code, this string. Because with this string now, we can pass it to the UA runtime as a worklet and execute it, because strings can be evaluated. And this is what Reanimated and Gesture Handler have been doing for years, and that's why they are so effective and popular, even though this whole idea is quite primitive. All right, but we were supposed to be talking about the future. Yes, we wanted to do like general computing with worklets on all the cores, not only the animations. And at this point, we have to talk about using libraries in worklets, because you are very familiar with the fact that you can use animation functions in worklets like with Spring. And this is because with Spring is a worklet itself. So we have access to its code, and therefore we can use it in worklets. But if we take some more general JavaScript libraries like Lodash or Axios, they have no notion of worklets. I mean, why would they integrate with some React Native library? Why would they mark their function as worklets? So to go forward at this point, we actually have to take a step back. And do you remember when we said that the new runtimes don't have the access to the JavaScript code, to the JavaScript bundle? Well, meet the bundle mode. And the bundle mode is an experimental feature in React Native Worklets. It's a feature that gives worklets access to your whole JavaScript bundle, meaning that any code present in your bundle can be executed in any worklet and on any runtime. So, sounds just great. And I want you to encourage using the bundle mode by explaining how it works. So, with the bundle mode, we can create any thread with a new runtime and have this thread have access to the bundle. It can be a UA thread, but for this sake, we are going to go for a background thread, and this runtime we'll call the worker runtime. So how does it work? How can we do this multi-threading? Because these instances of JavaScript virtual machines are not connected in any way. Well, let's look at the example. Let's say we have a simple universe.ts file that exports a function load universe that does an HTTP request with Axios. And then we have our app.tsx file, which exports a component which uses this function load universe. And we want to offload this request to another thread. So we add a worklet directive to our load universe function. We create a new runtime with create worklet runtime from React Native Worklets. And finally, we offload it to the new runtime with the run on runtime function. So the API is really simple, but still the problem is, how do we tell the new runtime to use its own load universe function when we are still on the React Native runtime? How do we make that connection? How are we linking the bundles? And well, to figure how to link them, we must understand the JavaScript structure, the structure of the JavaScript bundle in your app made by Metro. And going back to our original files, if we look at what kind of bundle it produces, we can see something like this. And usually the bundle is hundreds of thousands of lines long. I may make it pretty short to only 1,300. And so this is a simplified version, which consists of some initialization, which is not important for us. But what is important for us are those __d and __r calls in the second part. What are these? Well, confusingly looking functions? Well, it turns out that __d stands for define, which defines a module in a lazy fashion, and the __r is require, which executes the module's code. It's basically just require as you would use in Node, but this is React Native and Metro. And what is important for us, that these are global functions. And I hope you can already see when we are going from here. If we look closely, we can see that Metro turns every single file into its own module. So we have app.tsx module, universe TS module, Axios index file module, and our last instruction, require 0, is the call that loads the app.tsx module. Because the require function, the Metro require function, uses module IDs to reference a given module. So if we want to be even more curious and look what does the define function do exactly, the define call for app.tsx, it literally has the code of our app.tsx file inside of it. So we have the function app that inside uses the load universe function. But what is most important for us when we are talking about linking the bundles is this part, the definition of the universe TS module and this number 1, the number of this module. Because we have several runtimes, but they all have the access to the bundle, and they all have the same number for each module, which means that we can tell a runtime to execute a given module ID, and we know which module is going to be called. So how do we tell a runtime to call such module? Well, again, we go back to the worklets bubble plugin, and we do a simpler transformation this time. We add a property to our load universe function, which is going to be its module ID. All right, but how do we get the module ID at this point? Because module IDs are assigned by Metro, and we don't know them ahead of runtime. Well, actually, turns out that there is a little function exposed by Metro called require resolve weak, which takes a file as an argument and returns the module ID for this file. And I'd like to say my thanks to Rob Hogan, who told me that and saved me probably, I don't know, weeks of work trying to figure it out myself or trying to make my own require resolve weak function. And all we need right now is to jump back to C++ and write some functions. We can write a getModuleID function, which takes a worklet, gets a property module ID from it, and returns that module ID, and write a runOnRuntime function, which takes a target runtime and a module ID. From this runtime, it gets its require function as __r, and call this require function with the module ID. And this is the module ID of the file we had our worklet in. And in this worklet, we used Axios. And we don't have to handle all of the imports ourselves, because this is already all in Metro. We are using the built-in system. And this is great because it means that, that every runtime now is symmetric. Yes? Previously, with the string approach, we had one runtime with the bundle and other runtime which had some bits of strings. And now everything looks just the same in some way. So we went from a single core doing all of this with a single runtime, from using as many cores as we want with a runtime each of them having access to the bundle. And this is thanks to worklets everywhere. And I really like to think that this is the future of React Native. There is still a lot to do with the bundle mode, a lot of obstacles, problems to solve. Things like fast refresh is a pain, and the setup of the bundle mode itself in your app is not exactly pleasant at the moment. But if we get enough momentum, we definitely can make it work. And I think this is really important, because if you get React Native worklets and the bundle mode, we can get the piece that is still missing in React Native for such a long time, which are web workers. So, thank you.